Hello, this is Miss Moore, and today during chemistry we're going to discuss significant figures. The essential question is, how is a significant figure determined? By the end of this lecture, you should be able to fully answer this question with confidence. Okay, here we go. What is the point of significant figures? Significant figures, also known as significant digits, and truthfully, most people refer to them simply as sig figs. So sig figs are a way to numerically represent not only the value or number of a measurement, but how close to the actual value or how precise the measurement is. As an example, if I weighed an object and came up with the measurement 152 grams. If this number is written in significant figures, it conveys two very important pieces of information. First, the number represents the mass of the object, 152 grams. Second, this number represents the level of confidence I have in the accuracy of my measurement. Last topic for today, significant figure rules. We were just discussing how to write a number using appropriate significant figures from a measurement. We are now going to talk about how to determine how many significant digits there are in a written number. We'll start by talking about non-zero digits. So when are non-zero digits significant? A non-zero digit is a digit that is not a zero. So a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. Okay, and luckily this rule is super easy. Every non-zero digit is significant. Let's try a few examples. If I were to write the number 2, 1, 1, 6, 2, 8, all of these digits are non-zero digits. So they're all significant. So how many significant digits are there in this number? I come up with 6 sig figs, or 6 significant figures. All right, how about another one? 8.296. This time, there's a decimal here. But the rule doesn't talk about decimals. We don't need to worry about whether or not there's a decimal there. We're just looking at the digits. So, all of the digits are non-zero, which means they're all significant. We have 4 sig figs. So when we're talking about non-zero digits, it's pretty easy to determine the number of significant digits. They're all significant. Let's next discuss when zeros are significant. Unfortunately, the when zeros are significant is a little bit more complicated than when non-zero digits are significant. Basically, sometimes zeros are significant, sometimes they're not. What I'm going to do is give you the two rules indicating when zeros are significant. If the zeros do not follow one of those two rules, then they're not significant. All right, so first of all, zeros between non-zero digits are significant. So if I had something like 2002, let's figure out how many of these digits are significant. The 2 and the 2 are significant because they are non-zero digits. What about these two zeros? Are they significant? Do they fall between non-zero digits? They do, which makes them significant. So all the digits in this number are significant. This number has 4 sig figs. Okay. Next, let's try 36.0005. All right, you'll note this time there's a decimal. And at this moment, the decimal doesn't matter. We're talking just about the digits. So we'll ignore the decimal. Again, the 3, the 6, and the 5 are all significant because they are non-zero digits. What about these zeros? Are they between non-zero digits? They are. So that means that all of the digits in this number are significant. So this particular number has 6 sig figs. Okay, hopefully you feel okay about this. We'll move on to the second rule. zeros before and after a decimal are significant as long as there is a non-zero digit before the zero. Okay, so this time we do need to think about the decimal. One more time, zeros before and after a decimal are significant as long as there is a non-zero digit before the zero. Okay, let's try several examples. We'll start with 600.0. Let's figure out which of these digits are significant. That's 6. Significant because it's a non-zero digit. All right, how about this first zero here? Is it between two non-zero digits? No. But is it before or after a decimal? Yes. And is there a non-zero digit before the zero? Yes. That zero is significant, as is this one. How about the third one here? It's after a decimal, and there is a non-zero digit somewhere before the zero, so it is also significant. So in total, this number has 4 sig figs. Okay, let's try 67.020. Okay, the 6, the 7, and the 2 are all significant because they're non-zero digits. How about this first zero here? It's between two non-zero digits, so it's also significant. And this last zero here, it's after a decimal, and there's a non-zero digit before the zero, so it is also significant. So this particular problem has, 5 sig figs. All right, how about 200? The 2 is significant because it's a non-zero digit. What about these 2 zeros here? Are they between two non-zero digits? No. Are they before a decimal? All right, let's stop and think about this. I do realize that normally, if there's no decimal written, there's a decimal implied at the end of the number. And while that's true, when we're talking about significant figures, the only decimals that matter are the ones that are written down. And being that there's no decimal written down, these zeros are not in front of a decimal. They're also not between two non-zero digits, which means they are not significant. This number only has 1 sig fig. Okay, one more. How about 0.0050? Okay, the 5 is significant because it's a non-zero digit. What about this 0? It's not between two non-zero digits. It is before a decimal, but there is no non-zero digit before the 0, so it's not significant. How about these 2? They also are not between non-zero digits. They are after a decimal, but there is again no non-zero digit before the 0, so they are not significant. What about that last one? It's not between two non-zero digits. It is after a decimal, and there is a non-zero digit before the 0. So this last 0 is significant. So this number has a total of 2 sig figs. Okay, that's it for the rules on determining sig figs. If you don't feel comfortable about this, review, jot down any questions that you have, and all we have left to do now are to try a few practice problems. All right, Sig Fig Practice. What I'd like you to do is on your own determine the number of sig figs for 1 through 5. So hit pause, try to figure it out, then hit play, and I'll go through it with you. All right, so for number 1, I calculate that there are 5 sig figs. The 8, the 4, and the 5 are all significant because they are non-zero digits. These 2 zeros are significant because they're between non-zero digits. Okay. For number 2, the 8, the 9, and the 0 are all significant, which gives us 3 sig figs. The 8 and 9 are significant because they are non-zero digits. The 0 is significant because it comes after a decimal, and there is a non-zero digit in front of it. Okay. Number 3, the 2 is significant and the 3 is significant. These two zeros here are not significant because they are not between two non-zero digits. They are not before or after a decimal. Okay? So this particular number only has 2 sig figs. Okay. Number 4. The 4 and 4 are significant because they are non-zero digits. The first 3 zeros, none of them are significant because they are not between non-zero digits. They are before or after a decimal, however, there's no non-zero digit in front of it. This last 0 is significant because it's behind a decimal and there is a non-zero digit in front of it. So this particular number has 3 sig figs. Right? And the last one is number 5. 4, 9, 7, 6 are all significant because they are non-zero digits. These 2 zeros are also significant because they are between non-zero digits. So we have a total of 6 sig figs. All right. That's the end of the lecture. As I keep saying, please review anything you're not feeling comfortable with. Write down your questions so we can talk about it. A calculated answer cannot be more precise or exact than the least precise measurement. A calculated answer is simply a number obtained by doing a mathematical calculation, multiplying, dividing, subtracting, adding, numbers coming from measurements. So the answer cannot be more precise. You cannot have more confidence. The answer cannot have more significant figures than the original measurements. So we have some rules to follow to ensure that our answer is not more precise, that our answer does not have more significant figures than the measurements themselves. Let's start with multiplying and dividing. So when multiplying and dividing, the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs. Remember, we do not want our answer to have more significant figures than the original numbers. We don't want to be more confident in the answer than we were with the original measurements. Okay, let's try a quick multiplication problem and practice this. So we'll multiply 3.06 times 21.33. And if you could plug that in your calculator along with me, make sure we all agree on the answer. I came up with 65.2698. As you can see, the calculator gave me an answer with more significant figures than either one of the original numbers. So we're going to have to do some rounding. The first thing we want to do is figure out how many sig figs, or how many significant digits, each of the numbers in the original problem have. So we'll start with 3.06. How many significant digits does 3.06 have? I say 3 sig figs, because the 3 and the 6 are significant because they are non-zero digits. And non-zero digits are always significant. The 0 is significant because it's between non-zero digits. All right, how about 21.33? How many sig figs does that number have? I say 4 sig figs because they are all non-zero digits and all non-zero digits are significant. All right, so now we know the number of sig figs in the original problem, 3 and 4. So how many sig figs should the answer have? Well, the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs. That means our answer should have 3 sig figs, which means we're going to keep the first 3 numbers, which means we've got to do some rounding. So let's do a little bit of rounding practice just in case. So when you're rounding, you start by looking at the first number you're going to drop. Okay. If that number is 5 or more, you round up. If the number is less than 5, you drop. Okay, in this case, the number we're planning on dropping is a 6, which is 5 or more. So our final answer, including appropriate sig figs, is 65.3. Let's try a division problem next. Let's divide 2.55 by 152.33. And again, if you could go ahead and put that in your calculator, make sure we agree on the answer. My calculator gave me an answer with a whole lot of digits. I got 0.016739972. Okay, my answer has a whole lot more digits in it than either one of the original numbers. Okay, so the next thing we need to do is figure out how many sig figs are in each of the original numbers. So 2.55, how many sig figs are in that number and why? I say there are 3 sig figs because all of those digits are non-zero digits and all non-zero digits are significant. All right, how about 152.33? How many sig figs in that number and why? I say 5 sig figs because, again, all of those digits are non-zero digits and all non-zero digits are significant. All right, so now we need to figure out how many sig figs should be in our answer. Remember that when you're multiplying or dividing, the answer should be rounded to the same number of sig figs as the measurement with the least number of sig figs, which means our answer should have 3 sig figs. All right, let's look at the answer. And before we can even figure out where the sig figs are, we need to review some of our sig fig rules. So if we look at this 0, could that 0 be a significant figure? Remember, for a 0 to be significant, it either needs to be between non-zero digits, which is not the case, or it can be before or after a decimal, but there needs to be a non-zero digit before the 0, which is also not the case, which means that first 0 before the decimal and that first 0 after the decimal cannot be significant. So our first 3 sig figs are 167. All right, so we're going to be dropping everything from the 3 on. One more time, let's review the rounding rules. If the number you're going to drop is 5 or more, what do? Round up. If the number you're going to drop is less than 5, what do? Drop. Okay. In this case, we're looking at a 3. The 3 is less than 5, so our final answer in appropriate significant figures would be 0.0167. Okay, so we have 3 sig figs, and plus those zeros at the beginning, which are not sig figs, they're placeholders. Before moving on to addition and subtraction, I'd like to do one more multiplication problem to point out a potential point of confusion with sig figs and rounding. So we'll take 18.3 multiply by 4,200. So if you guys could put that on your calculators and check me, I got 76,860. Okay, so let's go back and figure out the sig figs for our numbers in the question. For the first number, 18.3, all of those are non-zero digits, which means they're all significant, so we have 3 sig figs. Okay, for the second number, the 4 and 2 are significant because they're both non-zero digits. The zeros, are they significant? Are they between non-zero digits? No. Are they before or after a decimal? No. so they're not significant. So the second number only has 2 sig figs. So our answer is going to have how many sig figs? 2. Okay, which means we're going to keep the 7 and the 6, and we're going to look at the third number here, which is the 8. And it's 5 or more, which means we round up, which puts our answer at 77. Hopefully you guys can see a bit of a problem here. 77 cannot be a rounded version of 76,860. They are completely not the same numbers. All right. So when you have a number and you're doing rounding and there's no decimal, you need to put placeholders in for all the numbers that you're going to drop or round. So basically think of it as rounding down. So we're going to put zeros as placeholders. Now, 77,000 can be an appropriate rounded version of 76,860. Let's switch gears a little bit now and talk about rounding calculated answers when adding and subtracting. Okay, when adding and subtracting, the answer should be rounded to the same number of decimal places as the measurement with the least number.